Already on number 2, started the video late. My apologies. So when I do inverse cosine here, angle A to the nearest degree, 14. Yeah, why do I have, wow, why do I have 16 up there? Why not? Sure, I just haven't been teaching this class all year long. You should have just let me just stand up there and be awkward. And there you go. Angle A?
Angle A, 50.
50 degrees, thank you. Yeah, I'm embarrassment. Questions? Good thing I'm not taking this. All right, same kind of unit here, because they do ask this type of question every year. I just want to make sure we're prepared. If cosine and sine are equal, there, cosine of 72 equals the sine of this angle, find the number of degrees in that acute angle. Do you remember when sine and cosine were equal, what I knew about their angles? It was probably a day, and I don't expect you to remember. If sine and cosine are equal to each other, their angles.
No, it's like a guess. It's like half.
No, Jesus. Stop. No. I'm so excited. Anything before I give it away? It can't be worse than that guess. No. Well, they could be if they were 45 and 45. There's a hint. But that's the only time they'd be equal. Cosine 72. How do I find out what it's equal to? Sine of. Okay. Some of you don't want to say it even though you know it. Here you go. A little note. So now we know it going in. Cosine of any angle is always equal to the sine of 90 minus that angle. Remember, if sine and cosine are equal, their angles are complementary. Okay, so if sine and cosine are ever equal, their angles are complementary. So how can I find angle x up here? I do 90 minus 72. If you ever see sine and cosine equal to each other, that must mean their angles add to 90. And now this makes it a pretty easy problem, huh? 18 degrees. Any issues? All right, next one. Still using this fact, just a little differently. Right triangle ABC. So if you want to get a little visual here, my right angle is at C. So make sure vertex C is your right angle. A and B are the other two. Stop right now before I even read the rest of it. What do you know about angle A and B in this problem? If C is the right angle, A and B have to add to what? Yeah, right. There's 180 degrees total. 90's taken, so everyone agree A and B have to add to 90 too. All right. Well, the sine of A is equal to this, and the cosine of B is equal to that. Hey, what do I know about these two in this diagram? What do I know about those two? Sine of A and cosine of B. Oh, the angles are complementary. Yes, the angles are A and B, but what do I know about the sine of A and the cosine of B? Those two are. Okay. Back this up. A and B add to 90, correct? So if two angles add to 90, the sine of one is equal to the cosine of other. So these two are equal to each other because A and B add to 90. So I can take 2x plus 0.1 and set it equal to 4x minus 0.7. Because you already know A and B add to 90, the sine and cosines are equal. And we should get 0.4 out for x. Questions? All right, so there's topic 1 today, which was sine, cosine, tangent. Now we go on to a big one that I'm a little nervous about just because I wasn't here to teach you this stuff. This is what you guys did when I was out, the quadrilaterals unit. There is a flow chart right up here. All right, there's a bigger one in your cold hard facts packet. All right, but we got to know our properties. All right, got to know something about the properties of every figure. Not, I'm not expecting every single property, but the main ones. And you'll see what I mean right away. All right, for number 5, a parallelogram must be a rectangle. So I got to know something about a rectangle. So go back to your flow chart. Take a look at the special properties of a rectangle. All the angles are right angles and the diagonals are congruent. Makes this problem a little easier when I know my properties. Right? So a parallelogram becomes a rectangle when its diagonals are congruent. Hey, let me just go through each choice first. Why I just circled 2. Diagonals are perpendicular. That's a rhombus. Opposite sides are parallel. That's still a parallelogram. That doesn't make it into anything because that's just a property of a parallelogram. Same thing. Opposite sides are congruent. It's still a parallelogram. Doesn't change it into a rectangle until the diagonals are congruent. And then 6, I should have taken that out. A parallelogram is always a rectangle if diagonals are congruent. So know the special facts about rhombus, rectangle. All right, now we get into some good stuff here. 7, here's a quadrilateral. What is it? What best classifies ABCD? Do you want to get rid of at least one of them right now? Or maybe 2 of them? Or 3 of them? Definitely can get rid of what? Trapezoid, right? Definitely can get rid of trapezoid. Anything else you want to get rid of? Why not? How do you know that? And don't even say because it looks like it. But we can test pretty quick that there's not a right angle there. Okay, how do I know that? Well, we can do, right? Okay, or Spence, go ahead. If you want to eliminate a square, in a square, the diagonals are congruent. Everyone draw in BD and AC for me. You can count those. I don't need the distance formula. Are those diagonals congruent? No, right? So that eliminates that it's a square. And if we know our properties, what other figure is the diagonals congruent? Rectangle, correct. So it's going to end up being rhombus. And also, too, if we went the other way, are those diagonals perpendicular that you just drew in? Are they? And that's a property of a rhombus. Diagonals perpendicular. All right. So quick elimination of those 3 because the diagonals weren't congruent. All right, you ready to buckle up here? We got some serious work for 8. I'll let you go ahead and do your graph here. It's a rhombus. Rhombus. Highlight here, rhombus. And we're given diagonal MT. 0, -1. And 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And I'm sorry, I apologize in advance. I didn't give you guys much room to work here because we're going to need to put some work down here, so I apologize. All right. Find the equation of diagonal AH. First question, everyone. What's this figure again? 11. Kelsey, what's this figure? Rhombus. Everyone go back to that flow chart if you don't know the answer to this question. What do I know about the diagonals of a rhombus? Because that's going to come into play here. I know MT and AH have to be what to each other? 3, Spence? Perpendicular. Diagonals are perpendicular. All right, so let's go back to yesterday now. If I'm supposed to write the equation of diagonal AH, I know these two are perpendicular. What do you know about their slopes then? 3 again, Spence, their slopes should be?
Which slope?
MT and AH, the diagonals. Negative reciprocals. All right, go ahead. Find the slope of MT. Let's start putting some work down now. Slope of MT, the diagonal I am given. You can do rise over run. We just use slope formula in the homework. Y2 minus Y1 over X2 minus X1. Somebody find the slope of MT for me. Up and over how many? When you have it, let me know. 6 when you're ready. Is that your boy? That's your boy, 6?
Yeah.
Okay, thanks. 2. Up and over how many? Or Y2 minus Y1 over X2 minus X1.
I got 7/4.
Darn right you did. 7/4. So that must mean, what's the slope of the diagonal we're trying to find? AH. We know they're perpendicular because it's a rhombus, and darn it, I know my properties. What's got to be the slope of the other diagonal? 8. Great job, Sophie. -4 over 7. Done. All right, I have the slope. What's the only thing I'm missing for this line from yesterday? What's the only thing I'm missing now? I have the slope, and the only other piece I need is the 13. I'm writing the equation of a line now. Think about yesterday. I always needed the slope, which I have, and the b value. Good. The y-intercept. Ooh, guys, the only thing I have right now is -4/7 to plug in for m, right? Usually I needed a point it goes through to plug in for x and y. So they didn't give me what AH goes through, but I can find it. What else do I know about the diagonals of a rhombus? They're perpendicular. I know they bisect the angles, but that doesn't help. And again, I'm just randomly putting AH here so you guys can see this. What do they do to each other? Bisect each other, which means they intersect at each other's. What's that going to be right there? Midpoint. Yes. So I need to find the midpoint so I can plug those coordinates in for x and y. So there's another formula for this beast. Midpoint. Anybody remember that formula? Woo! Yeah. Welcome to the Regents. Add your x's, divide by 2. Add your y's, divide by 2, right? x1 plus x2 divided by 2. y1 plus y2 divided by 2. So find the midpoint of MT. And it's the same midpoint as AH because they bisect each other. So 0 plus 4 divided by 2. -1 plus 6 divided by 2. It's not going to be pretty here. We got decimals and fractions working. Two and 2.5 for the midpoint. So that's what AH goes through. So now I can go back and find B now. I can take 2.5, plug it in for Y, and I could take 2, plug it in for X. I needed a point that that the diagonal went through, and it goes through the midpoint. All right, go ahead. Work your magic on your calculator. Find the B value, and we'll put the two together and finish this problem. Again, this B value is not going to be pretty, so you might want to leave it as a fraction at the end. And again, I know it's not pretty. I warned you, 51 over 14 for your b value. And then now put it together, write the equation of that diagonal. Y equals, what do we find as the slope again for that diagonal? 10, slope?
Negative 4/7.
Yeah, excuse me. Negative 4/7 x plus 51 over 14. And as complicated as that looked, we don't even start this problem unless we know diagonals are perpendicular. All right, diagonals perpendicular. So I can do negative reciprocals. All right, one more tough one here today, and then it's kind of smooth sailing for the rest of the class. Number 9, parallelogram has A and C as the coordinates. Which statement would prove ABCD is a rhombus? All right, I got to figure out what AC is, though. Is it a side? Is it a diagonal? Can somebody help me out? Maybe I just want to do, remember in the back of your packet, when you have your exam on game day, you'll have formula sheet and you'll have scrap graph paper. Okay, so use it if you need it. All right, so I'm just going to draw out a quick sketch here so I can figure out what the heck AC is. So 0, 7's right here. And 2, 1 is right here. Hey, kiddos, can you help me? What is AC here? What is that in the rhombus or in the parallelogram? The AC's a what in the parallelogram? 9? What is that? If I plotted B and D, AC would be a? Would it be a side? Remember how I label A, B, C? It would be a diagonal, right? Because I got to do it in clockwise or counterclockwise order here. So it would be a diagonal. So how do I do diagonals with a rhombus? What's the key property? Diagonals of a rhombus are, we've been talking about a lot today. 10? Diagonals are perpendicular, yep. So let's go through these. The midpoint of AC is 1, 4. Remember, we're not looking for a true fact. We're looking for a fact that makes this bad boy into a rhombus. All right. The midpoint might be 1, 4, but would that make this into a rhombus if the midpoint's 1? No, I still don't know anything about the diagonals. What about the length of BD is radical 40? If the diagonals were congruent, would it make it into a rhombus? No, it would make it into a rectangle. Gone. All right, what about slopes right now? Can you guys go ahead, find the slope of AC for me real quick. Rise over run or your slope formula. And watch this magic. Find the slope of AC for me. When you have it, let me know so we can finish this off. 6 when you're, nope. 12 when you're ready. Slope. Can I write -3? Is that all right?
Yeah.
Okay, thank you. -3, it just works a little better with my answer. -3, flip it and change the sign. What do you end up with? 1/3, don't we? All right, so yeah, if BD was 1/3, why am I picking 3 versus 4, even though both of them have a slope of 1/3? Which one's the other diagonal? BD, right? AB is a side. I don't care if AB has a side of 1/3. All right, I want the other diagonal to have a slope of 1/3 because they'll be perpendicular. All right, ready to get on cruise control here. Parallelogram, so let's know our properties. Angle R, 124. Boom. AF congruent to DF. What's angle AFD? Everyone see AFD up top? All right, get there for me. I'm going to start calling out people. Can you use properties of a parallel or any geometry? Let me put it that way. Use any geometry here. Label another angle for me because I don't think we're going to get to AFD right away. So angle R is 124. Can you get to another angle for me that you're pretty confident in? 10.
Is FAD 124?
FAD. That's Remember, which one's the parallel? You're close. All right, which one's the parallelogram? This whole thing's not the parallelogram. FRED is. So what do you change it for? You see it. Yeah. There's 124. Opposite angles are congruent. Keep using your geometry now. What's another angle you're confident in? 7?
ADF.
Yep. 56. Those are linear pairs back in the day. They're supplementary. Keep using your geometry. That was great. We used the parallelogram property. We just used linear pairs. Now we're going to use something new from another unit. Another angle you're confident in. 11, Kelsey. Look at the triangle.
AFD.
Which one?
AFD.
The one we're looking for?
Yeah.
Why do you say 124?
Because opposite or the parallel lines.
Okay, they are parallel. Those are the ones you're looking at. Those are your alternate interior. Okay, these aren't going to be alternate interior. These will be.
So DFR is
56. Yep, we're working there, right? We're working there. What other angle? I want you to look specifically at the triangle AFD and what we mark there. What type of triangle is it? Kelsey, on the hook again. What type of triangle is that? And what do we know about isosceles? Congruent sides and? There you go. So this angle A also has to be 56, right? And then now, can we find the missing angle? Side angle AFD. Let me know when you're ready here. 4? 68. Yep, subtract 56 and 56 from $1.80. Good. So remember, isosceles triangles, the angles across are congruent as well. All right, last topic. So there's your quadrilateral review. Last topic. Always a question on there, so I want to make sure you're prepared when I rotate polygons. So I got a pentagon up here. It's regular. What's the minimum number of degrees to rotate it onto itself? Meaning, rotate it onto itself. Everyone see the pentagon I have up here? How many degrees must I rotate it so I get that same looking pentagon back? Okay, how many degrees did I just rotate that? That's what I want to know. How many degrees? Ready? Again. How many degrees did I just rotate that to get the pentagon back? Easy way to do it is, try that again. Easy way, if I go all the way around, I'm going 360 degrees, right? How many turns would it take for me to go all the way around? Spence?
5.
Number of vertices, 5. So I take 360 divided by 5, the number of vertices, and that'll give you how many degrees I'll rotate it. So 72. It could be as easy as that, but it might get a little trickier with number 9. Now you have a decagon. Ooh, decagon, anybody? 10 sides. All right, way to redeem yourself. 10 sides. So we're going to go 360. Oh, I remember doing these in class. 360 divided by 10. And I end up with 36 degrees, but that's not a choice. Right? Well, am I wrong? No, we're not. This question doesn't say what's the minimum number. It just says, hey, find the number of degrees it would take. Well, 36 could do it. Or do it again, 36 degrees. 72 degrees could do it. Nope. I got to do every 36 degrees, I could rotate it onto itself. So now we keep adding 36, add 36. When do I see a choice? Add 36. And of course, it takes you for a while. And you should end up at 252. Okay, so make sure you keep adding that number every time, because that is also a correct answer. Whew. All right, we good? All right, we got a lot of practice here, as you can see tonight. Let's get going on it. It's a lot of quadrilaterals, sine, cosine, tangents. Your grade will reflect the effort you put into it. I always believe that. Still out of the same exams. Ooh, what's tomorrow? Similar triangles. Ooh, dilations.
Cosine 10. So cosine is adjacent over hypotenuse. So ratio cos 10. Okay, you could do the hypotenuse to find 10 L. Opposite or adjacent 12. So it's number 1. What polygon is that? Rhombus does. Oh no, it doesn't do it. Square does.
Yeah, you picked the only one that doesn't.
I was thinking, alright, yeah.
So let me make that picture of the shot that you might do. That's a pretty easy picture.
What?
You know the sandwiches that were there yesterday?
Yeah.
I'll show it to you after class.
Shot them was
Put in one of those little white
Daniel.
notes.
Shot?
He's who got a picture of him and he's like,
Yeah, I tried there. Thomas has so you go all the way.
Who's that is such a rule of
So
law.
this came up.
Sean Taylor's dad just like
He take
you
the
want me to speak.
It take
Yeah.
3 minutes. 3 minutes.
we'll never catch him going 5 over.
He was in this little.
Yeah.
I was like, it's
If they drive home after a car, like
no, it's like
Yeah, but he drives, no, it's not a Volkswagen, it's a car.
It's like a tiny.
No, yeah, it's a little sedan. Drives over.
No, it's not a sedan. It's like a
It's got
smart car.
Oh, he was in that one?
He was in that one, yeah.
I've got 2 cars that felt like a 4-door.
Sean told me he wasn't coming last night. He
Because
showed up anyway.
I always kept
he knew they were gonna have sandwiches.
He was actually, he's like, really chill. He's just,
He's always lurking though.
He's slightly weird and pretty chill. If I wish I had an award for most times putting the poetry box. Absolutely.
It flows along for me.
8 minutes.
Hey,
How was that one on CBA? That was awful.
It's not meant for. Oh, yeah, it's for the diagonals are congruent. D.
It's where the diagonals intersect.
Okay. B E. I got that. B E S T equal E
It's delete. Yeah, I was gonna say.
Oh yeah.
So it's just like
That's what I've been saying. I've been saying that.
what?
What is it?
This is definitely.
Why is it? Wait, is that a step?
I don't know. Wait, you know what? You know what?
What is she?
What? That's kind of stupid. Why would you do that?
It's hard, bro. What do you expect?
Wasn't it like one too?
Yeah.
It's supposed to be an art grade. Everybody says the only reason we won our last game was because Marky was
Probably right though. Yeah, well, either would have gotten so. Either would have missed everything. It's more fun. I'm not taking the next year though. Mr. Jeffries is teaching American literature.
I'm just taking regular English because I'm like literally everything. It's boring.
Thank you.
See you guys.